We're going to wander a little bit off the map today because I want to talk about two things that are in Python that the book's not going to cover at all. So it's kind of okay if it flies over your head. You'll see this stuff again in scripting. But I'd like for you to walk into scripting feeling all real pumped up, right? You know. So at least in the background, in the back of your head, you'd have the idea. And one of the ideas is the idea of object-oriented programming. Oh, what's that? That sounds scary. Well, not a big deal. We'll give an example of it. And if it clicks with you, great. It's going to be an important topic if you go on to take Java or if you take scripting or something like that. If you don't take those, fine. You know, you'll have an idea of it in your head anyways. But it's not in the book, so we're going to cover it on our own. But we're awesome like that. We can do it. So far, right now, we have been dealing with either individual pieces of data or, as I mentioned, okay, we're in Lecture T. We have been using individual pieces of data. Individual pieces of data. Someone's age, or pay hours, or rate, or something like that, right? We just introduced the idea of using an array of data. Like a series of scores or names, right? These are all the same type, right? All your scores are going to be numbers, all your names are going to be string. But there's a third kind of data. Let's just cut off the edge again. Yeah, barely not. All right. What about our good old turtle class? Our turtle class is a lot more than an individual piece of data, and it's not a list. Like, what does the turtle class have in it? It's got to have an X and Y position on the screen. It's got to have an angle that it's going at, right? It's got to have the color of the pen. It's got to have a speed. And a whole bunch of other things, like whether the pen is up and down, or the thickness of the pen, or what the shape of the cursor is. We didn't play with that, but you can make the cursor a turtle or a triangle or, you know, a circle or whatever. But here we see at least 5 pieces of information all in one turtle object. So that turtle is a group of pieces of data. So now we're going to say that an object, well, let's redefine things. A variable holds a piece of information. You could call it item of information, something like that. An array holds a series of pieces of information called elements. Now we're going to talk about the new one, which are objects. An object holds a group of information pieces and functions that act upon that information. And I could go back and I could change the word information to data, right? A variable holds a piece of information. An array holds a series of pieces of information. And an object holds a group of information pieces and functions that act on that information. Well, what do I mean by that? Well, when we told the turtle to go forward, it used this information to draw a picture on the screen. It had to use its X and Y, it had to use its angle and the color of the pen and the speed, and once it drew the picture, once it drew the line, it updated its X and Y. Or if we told it to go left, Then it updated the angle, right? And then we told it to go forward again, and it used that XY position in the new angle. So we had those functions that we called. Like the turtle, for example, has some pieces of information, right? The data that it contained. Now we're going to give it a really fancy word, members, or member variables. And then it had some functions with our really fancy name of methods. Get all computer sciencey on it. And the turtle class has methods like going forward and left and right and color and speed. It had all those functions that use the data. All those functions used or updated the data. Right? Changing the color would update that one. Changing the speed would update that one. Going forward would use that and that and that and that to draw the line on the screen. And then turning left or right would change the angle. Now we could write a program that just kept track of all these in variables. Right? We could say x is equal to 30 and y is equal to 40 and angle is equal to 60 and I want you to go forward and I want, right? But that would only handle one turtle. What if we wanted 2 turtles on the screen or 20 turtles on the screen? We could do that. We could put all that information on the screen. And so we're going to play, if you feel like typing along, with having more than one turtle on the screen. We're on Lecture T. All right, so every time we play with the turtle library, to refresh our memory, we have to import turtle. And now we're going to make a turtle. Fred the turtle is equal to turtle all lowercase, dot, turtle uppercase, parentheses and parentheses. And we're going to set some data for him. Fred is really speedy, so Fred.speed is equal to 10. Fred.speed, parentheses 10. Fred is green, so Fred.color, parentheses, quote, green, end parentheses, end quote, end parentheses. That's probably enough information. What did we say the turtle can hold? It starts off with an angle of 0. It starts off with an X and a Y position of right in the middle of the screen. We're not going to change those. Those get changed by drawing. And then the color of the pin and the speed. But yeah, we want another turtle. Not called Fred. This is going to be called, I don't know, Leo. Leo's easy to type. So that's our first turtle. Fred is equal to turtle.turtle. Here's another one. Leo equals turtle.turtle, parentheses in parentheses. Leo is slow. Leo.speed, parentheses 0 in parentheses. He's a different color. Most turtles are green. He's brown or red. Leo.color, parentheses, quote, red, in quote, in parentheses. Now just make sure your code compiles if you're typing this along. Run the module. Make sure we don't have any syntax errors. Now we can't see what's going on because both we created a green turtle, but then we slapped a red one on top of it, and the red one's covering it. That's okay. Anybody got? Wow, how can y'all see that? Probably better. Anybody got syntax errors you want me to come eyeball? All right. So Leo's going to go up, so he's going to have to make a left turn. Or Fred. Let's move Fred first. Fred.left, and he's going to go 90 degrees. He's going to start drawing straight up. Leo's going to go a different direction. Leo's going to turn right and go 45 degrees. He wants to go to Florida. Well, I guess Fred's moving to Canada. Now Fred, since he goes so fast, he's going to draw a long line. Fred.fd or Fred.forward. I'm just going to type FD because it's easier to type FD. He's going to go 300 pixels. Leo's going slow. He doesn't want to go as far. So Leo.forward, 150 pixels. Now, lastly, they're both show-offs. They want to make loop-de-loops. Fred.circle with a radius of 50. And Leo.circle with a radius of 25. He's just not as ambitious. All right. And we see we have two turtles. I'll bring the code back. We have two turtles on screen doing completely different things because each turtle is keeping track of its own information. And that's the way the real world is, right? I have a name, I have a height and a weight, and I have an address, right? And you have a name, and you have a height and a weight, and you have an address, and probably all that information is different. Yeah, maybe we're the same height or something like that, right? But not all of those things are going to be, the same. You're carrying around your data. Michael's carrying around his data, and so on, right? We have two different computers on the network, right? One's got a different IP address than the other. One's got a different operating system than the other. One's got, running a different, version of the operating system. One's running a different processor than the other one, right? So in real world, their traits differ. And that's the way these turtles are going. Now, we don't have to just create two turtles. We could create 1,000 turtles on the screen, or 100 turtles on the screen, or 20 turtles on the screen. Let's do that just for giggles, and then we'll be done with this part of the lecture about turtles. We may comment it all out or something. So I feel like creating 10 different turtles. For x in range, parentheses, since I want 10 turtles, I'm going to do 10, but just as a reminder, that counts from 0 to 9. We're going to create a turtle. T equals lowercase turtle dot uppercase turtle, parentheses in parentheses. And we're going to send, tell you what, I want them to go like 360 degrees, right? Change my mind. So from 10 to 361, updating by 10. So that's going to count from 10 to 360 by 10s, right? We're going to have 36 turtles on the screen before we're done with this. That's okay. Not going to break the computer. So t is equal to turtle.turtle, and then t.left by x. So the first one's going to turn 10 degrees and go forward. The second one's going to go 20 degrees and turn forward. And the third one's going to go 30 degrees and turn forward, right? And then so t.forward, 100, right? Each one's going to turn a different angle and then take off. And we're not going to mess with changing their colors or their speeds or whatever. I think this is enough to illustrate the point. There we go, right? He was going fast at first, and it seems like he slowed down.
He is slowing down.
That's funky. Maybe the more data on the screen, the slower he goes. Yeah, anyways, that's kind of a cool picture. And the way it was accomplished is we created 36 different turtles. We could stick all those turtles in a list if we so chose. And we could keep making them do things, right? Because what is a list? A list is a series of data. Well, you can stick turtles in a list just as easily as you can stick names or student scores or stuff like that. All right. Hope I've convinced you of the idea of an object. Each one of those turtles is an object that carries around its own information, its color and its X and Y coordinate and what angle it's going at. I like that. I'm going to have to demonstrate that again in another class because I like the way that drew it. All right. That kind of makes sense. And also, did we get syntax error? Do we need to fix something? All right. How you doing, Michael, or did I lose you?
You lost me.
So you just
by a couple of lines.
a couple lines. All right. So I'm going to add some notes. Just like I said, an object is a collection of data, and the functions, technical term methods, that uses that data. And I'll go ahead and put the fancy word for data after the word data, parentheses member variables. A class is the blueprint for an object. Turtle is a class. Leo and Fred are objects. Turtle is the class. Leo and Fred are the objects made from that class. Just like you're going to build a big old custom fancy house. You go and you find some blueprints for it. You build your house. Your neighbor's jealous. He builds the exact same house. So he uses the exact same blueprints. Still, it's different, right? It's at a different address. It's not the same house. You're not living together. He built his own house. And then somebody else in another town uses the same blueprint, right? It's the same blueprint, but you're making different objects based on that blueprint. Each object is different. Each object occupies a different space. Each object in our computer occupies different memory, so it can keep track of all of its data. So, just like you have a house blueprint and make a lot of different houses from that blueprint. So let's define a class. What are we going to put in our class? Well, my brain, being the way it is, I always go towards like geometry or something like that. And I don't know if we want to do that, but I think it demonstrates the idea pretty easily. Let's do a geometry of a rectangle. Or now, let's not do that. We've been doing payroll, so we're going to make a payroll application. So we need a class for a worker. Class worker, colon. Now, just by convention, programmers usually choose an uppercase name for the class. Pick an uppercase name, you know, an initial cap. If it was all caps, you'd pretend it was a constant. All right. Now, here's where the syntax is going to get a little bit weird. So you're going to have to type exactly what I type. And what I mean by that is you're going to be using double underscores in places. Not a single underscore, but a double. So now we're going to add some functions to our class. How do we define functions? With the DEF keyword. But in the past, our functions have been all, you know, against the margin. But these functions are part of the class. Just like I said, an object is a collection of data and methods, functions. Well, we need to define our functions, our methods, as being part of the class, so they're going to be indented. DEF. And this function is the one that is used to create the object, like you create a turtle, you create a worker. So DEF, 2 underscores, and make sure you get that space there. INIT, underscore, underscore, parentheses, SELF, in parentheses, colon. We'll talk about why we had to put self there in a minute. Just kind of trust in the force for a little while. Self.name equals empty quotes. Self.hours, the hours he worked this week, is equal to 0. Poor guy. But he doesn't have a name, so he doesn't care. And then self.pay rate is equal to 0. Now we need a function that's going to calculate his pay rate. And yeah, we've been doing fancy ones with overtime and stuff like that, but forget that. We're just going to multiply his hours times his rate. No overtime in this outfit. All right, so DEF get underscore pay, parentheses, self, in parentheses, colon. And this one is just going to multiply the hours by the rate. Notice that all of our variables so far have had self dot in front of them. Like I said, we'll get back to that. So P or R for return value, something like that, is equal to self dot hours star self dot rate, and then on the next line, return R. We're going to need one more method. We want the worker information to be able to be printed in the form of a paycheck. So we're going to add one more method, one more function called print underscore paycheck, although that's kind of long. Maybe just print check. So DEF print underscore check, parentheses, yet again, self, in parentheses, colon. All self means is that we're using this object, all the variables that are part of this object, like my self name and my self's age and my self's, whatever. So let's print out our information. Print parentheses quote paycheck for, in parentheses, comma, self.name. Self.name, in parentheses. Print, parentheses, quote, pay equals $, end quote, comma, get underscore pay, parentheses, in parentheses, in parentheses. Now I may be making a typo here. I'm wondering if it needs to be self.getPay. I think it does. So before get underscore pay, I'm going to add SELF dot, just because I want to make sure it works. All right. We're about ready to use our worker object, our worker class. Oh, and by the way, we don't want to draw that stuff on the, we don't want to draw the turtles anymore. We probably better comment all this turtle code out. You can always uncomment it if you want to see it draw it again. The only reason why is I don't want to have to watch it draw turtles every single time I test my program. So I added triple quotes above my import statement, and I'm going to add more triple quotes underneath my for loop, just to get it all green, get it out of the way. All right, I want to make sure I don't have any typos. And I want to make sure y'all don't have any typos either, because if we have typos now, it's not going to work later.
So with your first def, you have underscore underscore?
Right, those are double underscores.
Because mine's not turning on. It's okay.
Make sure you got a space between the def and the underscores.
Initial. Underscore, underscore. Still not turning.
Let me come eyeball it. All right. We're going to define three people. Gilligan. If that's too hard to type, just type Gil. Gilligan equals worker, parentheses in parentheses. Tell you what, don't call it Gilligan. I'm going to get real tired of typing Gilligan over and over.
Nothing happened when I
That is exactly what's supposed to happen. We were doing a syntax check, but we didn't actually have it doing anything. We defined our class, but we didn't actually call it. So it's not supposed to do anything. But we're going to make it do stuff now. So G1 is equal to worker. But he needs a name. G1 dot name equals, quote, Gilligan, or call him Luke, or whatever you want to call him. Make up your own names if you like. G1 dot hours, he's a hardworking guy. He worked 40 hours this week. And G1 dot rate, well, he doesn't earn as much as anybody. He's only earning $5 an hour, poor guy. Although that was a lot in the 60s. Let's create some more workers. Same syntax. So like G2 is equal to worker, and then just make up some other stuff. G2 equals worker, parentheses in parentheses. I did start the recording again, did I not? All right. G2 dot name equals skipper, end quote. G2 dot hours, well, he was not feeling it. He worked fewer hours. But being the skipper, he earns more. G2 dot rate is equal to $20 an hour. All right, what was the name of the millionaire on that show? I don't remember. Y'all even know what I'm talking about. Gilligan's Island.
Oh, Mr. Howe?
Yeah, Mr. Howe. All right, I'm going to do Ginger the actress instead. G3, I don't know why I came up with G's, is equal to worker, capital W. G3 dot name is equal to, quote, Ginger, end quote. G3 dot hours. There's not a lot of call for an actress on the island. One. But she earns a heck of a lot of money for her appearances. So G3 dot pay is equal to $10,000 per hour. Now let's print some paychecks. It's going to be G1 dot print underscore check, parentheses in parentheses. God bless you. G2 dot print check, and so on. You know what we could have done to speed up our data entries? Just copied and pasted and changed some stuff. So G1 dot print underscore check, parentheses in parentheses. G2 dot print underscore check, parentheses in parentheses. G3 dot print underscore check, parentheses in parentheses. See if that works. Give it a run. Pardon me?
Is the lesson supposed to be paid like G3? Or is it really?
We're not calling dot pay because print check calls get pay.
Oh, okay.
Oh, did I make a mistake here?
Right there.
Rate. You're right. That's wrong. Thank you for catching that. That was the pay rate. So replace that word pay. Sorry about that. Thank you for catching that. Fix this. And make sure you fix that line. All right. Pay is equal to $200. Pay is equal to $200 and pay is equal to 10. Now I need to go eyeball it and see why Skipper and Gilligan earned the same amount. Maybe that's correct. Maybe I just happen to choose hours that multiply out to 200. 10 times 20 is 200. 5 times 40 is 200. Yeah, they did. I'm going to change Skipper's pay to $25 an hour just because I want to see some differences. So you see what I'm saying? We have each worker object is a cluster of information containing their name, the number of hours they worked, and the number and the pay rate. That's the idea of object-oriented programming. It can get a lot more complicated than that, but we don't need to learn a lot more complicated than that. We're just learning the fundamentals. That's object-oriented programming in a nutshell. You make a class that's the blueprint for an object, and the object is a collection of data, in this case name, hours, and rate, and the methods that work on it, like get pay or print check. For grins, what I want y'all to add is one more person on your own. Make a G4 and tack some more people on. And I should have had you do that while I was wandering around. So just create a G4 equals worker and customize it with your own whatever information you want. All right, I'm going to leave the rest of that as an exercise for the viewer. You know how to do it. Pause it and figure it out. All right, that's about enough of that. Let's go back to the PowerPoint about lists. So you can search an array for an exact match using what's known as a linear search. Right? If you have a series of data, sometimes you want to find that piece of data, like you want to change it. That's called a linear search if you start at the beginning and you go to the end. Right? You keep going. So let's define an array. See, I use those terms interchangeably. Let's define an array. I don't know. That's just a list of numbers. Those are the easiest to type in, right? Nums equals, heck, why not just a capital L? That's even easier. Now remember I showed you that you could create an array like this. Don't type this, I'm going to erase it. Right? 0, and then now it's 20 elements long. Right? And we're going to use the other syntax, the initializer list. Type in the square and just type in some numbers. It doesn't matter how many numbers there are. What their values are. Next thing we ought to do is maybe print all those numbers and then ask the user if they want to change one of them. Which number do you want to change? Let's do that. Let's ask the user, or let's print out the numbers first. So print parentheses. Let's be professional and actually print the data out. So for E, short for element, NL, short for array. Heck, I could have made that in a capital A, right, to mean array. Colon. Print parentheses E, comma, let's make it all fancy so it's all on one line rather than lines underneath each other. So E and D equals quote, comma, space, end quote, in parentheses. Now, if I ask you on an exam to write a loop that prints out an array, you can leave off that end business, right? Because it would still print it. It would just print all the numbers each on its own line. And so,
what did you say A for? You said,
oh, sorry.
or E.
I could have done this. I could have made it look like that. I could have chosen a different variable name, but variable names are meaningless to the computer. I could have called this gobbledygook, you know, as long as I typed in the exact same thing here. So I'm going to go back to calling it L. And if I said for E and A, that was my mistake. Let's go with that. Now, let's print a blank line to go to the next line, and let's ask the user what number they want to change. So I'm going to call the number that they're looking for search, although it's, you know, 6 letters long. We're tough, we can type it. Search is equal to input, parentheses, quote, change what number. I just use a number sign to make it easier to type. Question mark, space, space, arrow, end quote, in parentheses. And we better change that to an int or float so that we can actually do the math and do the search. So we could do search is equal to float search, or search is equal to int search. Search equals float parentheses search in parentheses. Just like we've been doing from the very beginning, every time we ask a user something, we print a message out. We use the input function, and then we convert it to a number if we're going to do math on it. I'm going to make sure I don't have any syntax errors yet. All right, great. Doesn't do anything, but it doesn't run without errors unless I type in garbage. Right? If I type in garbage, it's going to blow up, but
Change what number? Okay.
Now we're going to do a linear search. A linear search starts at the beginning and uses a loop to find the element that matches. Now there's two syntaxes we could be following, but we're going to use the syntax that lends itself towards actually being able to change items in that array, which is the index-based loop, which is what we have been using all along. There's another syntax for traversing a loop, traversing an array, but it's Python specific sort of, so I'm going to skip it for now. For I, like index.
We're doing Python specific though, right?
Yeah, but I don't want to veer off the path of what we learned last lecture. So for I in range parentheses len parentheses l close parentheses and another close parentheses and a colon. In other words, we're going to be going through every item in the array, so we need to go out to the end of it, so we're using the length function to get the length of the array. So if we go back and add some data, I don't want to just put like 10 there because I'm not sure if I have 10 items, and if I did, then I might wind up going back and adding some. All right, now let's check. Let's see if the item, that particular element, matches our search. So if L subscript I, if that particular element in our array equals search, the one we're looking for, colon, we're just going to print yay, we found it. For now. Print parentheses quote, yay, we found it. We'll change that to something better. And then I'm going to put an end for comment at the end of it. Alrighty. I'm going to run it and test it out. If we don't see the message, yay, we found it, we know we never did find it, which is kind of a drag. We're not printing that message. Change what number? I want to change 123. Ooh, it printed it twice. Oh, I guess I typed in 123 twice. Alright, that's legit. To make that yay, we found it message, if we wanted to be able to print a message that said we never found it, we'd have to set a flag. And what do I mean by that? We'd have to have some variable that said found equals false or found is equal true, something like that.
Mine just printed change what number.
Right, and did you type a number in?
Nope.
Yep, type a number in. If I run it and I don't type a number in that matches,
I got a syntax error.
all right, I'll be there. I type in a number that doesn't exist in that list, it didn't print anything. And I'd like to fix that, and I'm going to do that via a Boolean variable or a flag.
Oh, I see my mistake.
So what do we need to do? Kind of like when we had an accumulator, or when we wrote our guessing game and we had a, like, you know, continue equals yes or repeat equals yes or something like that. We need some signal, whether we found it or not. But we're going to set it equal to false.
Yeah.
Found equals false. But if we ever do find it, we're going to set found equal to true. And then we can check that flag after our loop and print out didn't find it. So found equals true, lined up underneath the print statement. So here's what we just added. And here's what we just added. And so down here at the bottom, we might print a message saying we did not find it. If found equals false, capital F, colon, print parentheses, quote, number not in array, end quote, in parentheses. I'm going to run it again and type in a number that's not in my list, just to make sure, because I want to see that message pop up. I want to see number not in array. Firstly, I'm going to type one that's in it. I see a 67, so I'm going to type in 67. Yay, we found 67. I'm going to run it again. I'm going to type a number that's not in that list. The number is not in the array. Okay. That's enough to illustrate it. We're not actually using the data, but it illustrates searching for it. We could use it. I don't know what we would change the number to. I'm just going to add a comment here saying now we could use that element of the array for some purpose. We could ask to change it or something like that, right? Oh heck, let's change it. Capital L subscript I in subscript is equal to 9999. Just to make it real obvious, we changed it. And I feel like taking that yay, we found it message out, like maybe commenting it out. Or maybe, let's leave it for now. But we're going to put an else statement under this if found, telling the user that we did change the data. Else colon print number in array was changed, end quote, end parentheses. Now we're cooking. Let's type in a number to change. I'm going to change the, that 123 was interesting because in my list it appears twice. And it says, yay, we found it, yay, we found it, number in array was changed. Maybe we ought to print it out again just to confirm that. Why not just copy and print, copy and paste that one loop that we wrote and put it down in here again? That's the fastest way. I'm going to scroll back up, find my little loop that printed it. I'll even add a comment to the effect that it prints the array on one line. And then make sure you get all three lines, the for E, the print, and then the print. Make sure you get all three lines, copy them, and then just paste them at the bottom. So the for loop that prints the array, I'm copying that and I'm pasting it and I'm putting it down underneath my if else. All right, again, I'm going to change my 123 because it appears twice in my. All right, and it did change those elements to 999. That's called a linear search. Why? Because linear means line, right? And we're going in a line, blah, 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 blah. Changing them as we go. There's another kind of search called a binary search. But the numbers have to be sorted to use a binary search. So to get that to work, we have to sort the data. And the way the binary search works is just like our guessing game. You guess a middle value, right? You look for the middle value. Is that equal to 1, 2, 3? No. In that case, you go back, right, half, or you go up half. Is that number equal to 123? No. Then you go half again, and you zero in on it that way. And we've already talked about how efficient that is, right? If you were going to guess a number between 1 and 100 on average, it takes 50 guesses. You just start at 1 and go on, to the end, like a robot. But if you can guess 50 and then go down to 25 and then go to 37 and then, you zero in on it, it takes like a maximum of 8 checks. So binary searches are a lot more efficient, but the cost is that you have to sort the data.
Would you paste? Would you just cut?
What I did is I wanted this loop that printed the array. So right under here where I declared the array, I copied those 3 lines and I went down here and I pasted them. But I think it's good enough as is.
Do I need to add that number that I changed?
I don't remember you changing a number.
It says number in array. Number in array was changed.
Yeah. Go ahead and add that too. Yeah. All right, I'm going to clean up a couple of things. We don't need that comment there. We don't need that comment there. Pretty close to the end of the class. Have we covered enough material to inflict another assignment on you? Let me think about that. So your last assignment, you created a list of movies or something to that effect. Movies or books or something. For this assignment, add code that will ask the user for a movie to change, and it will do so with a linear search, as shown in this lecture. Only difference is I don't want you just to change it to 999 or something. I want you to ask for the new name. Be sure to ask for both the name of the movie to change and the new name, the name you want it to be. So there will be another input statement where we had valid found equals true. So what's the difference? You're going to be asking for strings rather than numbers. You won't need to convert them to ints. Make a couple other changes and you'll be there. And if you get stuck, ask me about it.